all of us on staff at the BINIA project have essentially had to figure out different things that they need in order to answer overarching questions. And so we wanted to try and create a way to impart that knowledge, 20 years of knowledge, in a more systematic way with students in the broader area, and have them come together to help organizations in the city of Baltimore that are doing good work. So for us, the BINIA team, we're working with Towson University, we're working with UMBC and Bowie State. Our role in this broader project, all of our institutions have fellows working with all of our institutions, and some of the students are here from different institutions right now. And our job, the BINIA job, was to try and find what are called host institutions. So host organizations that have that question, a question that maybe none of us would have ever asked, but because these organizations are in the trenches doing the work, they are trying to figure out how they can get into using their data science skills to answer that question. So that's the basic idea. This is the first time, this is the first semester this summer that we actually opened up the ability to be a host. So all of our hosts are our guinea pigs as well. So thanks to all of you that are here as our host. And for those of you that are a host, please, in either the chat or in your name, if you want to rename yourself, let us know who you are. But this website, which I'll put in the chat as well, is a way for everybody to kind of see past projects that were where BINIA itself was the host, or we kind of forayed with kind of curated hosts in the past, like the city itself, or people that we had identified that might have a question. So this is our first summer where our hosts were unknown to us. They came to us through a form that we created at the beginning of the summer. The form will open up again every semester. So if you are interested or know somebody who might be interested, feel free to join us in the future. And so you're going to hear from 5 students today, and they are midway through a question that they're trying to answer. They have the rest of the summer to flesh it out. And you're going to hear kind of where they are, what they've been learning, where they're thinking they might go towards the end of the semester, and how data science is useful to them and their future potential careers. So I'm going to turn it over to our first student, and that is going to be Amivi.
Hi, everyone. So my name is Amivi Atsu. I'm a junior at the University of Baltimore, and my presentation is on DataWorks MD. So I'm going to share my screen now. Okay. So data exploration for DataWorks MD. So what's DataWorks MD and what is my role? So DataWorks MD is an organization of professionals, students, and enthusiasts who live and work in Maryland and who are interested in topics related to data science. So they organize monthly events, they publish a newsletter, and they work with local organizations to engage with the purpose of engaging the data science community, like in Baltimore, all over the place. So my role in this project is to collect various data, to create a documentation about the process I followed to collect those data, and to analyze, organize that data in a way that would be helpful to DataWorks MD and to other organizations in the area. In a way that, again, that will increase the value that they bring to the community. So the questions that we are trying to address are, which cities are the members from? So for my project, I'll be really focusing on the DataWorks MD, the meetup group. So I'm working with the data from the meetup group. So trying to get which cities are the members from, when did the members join? Did the membership sign up increase during the COVID-19 lockdown? So we want to know which cities they are from, because based on that, we can the group can figure out where to organize events, where to have like events and things like that. So when did the members join? Was then increased during the COVID-19 lockdown. What other meetup groups are the members from? How often has a member attended an event? This question helped to find out the star members, so the one who attend the most events, and it's helpful to reward them. So what's the correlation, or what topics or activities are the members interested in? What's the correlation between all those data that I'll gather? And then what needs and wants transpire from those data? We want to know what do the Maryland community, the data community really wants, and then cater to those needs. What's the demographic, the careers and ambition of the members? So we just want to know everything about them, about this community, and then just cater to their needs. So data science tools that I've been using for this project are Meetup API. So this allows me to extract important data from the Meetup group. So when we go on the Meetup group, we can get some information, but we can't get really like important data or some really deep information. So with API, with the Meetup API, we can get those information. So to extract those information, I need to use some code language. So Python, I'll be using Python for this project. And then JSON, when we work with code, sometimes we get, again, some code that no one can really read. So with JSON, we have the opportunity to actually make it readable, human readable to anyone. So yes. So Meetup API. So to get access to the Meetup API, it was a whole process. It was a whole process. But finally, to access the Meetup API, we need 3 handles. We need the public-facing client ID. And to get that, the owner of the group need to get the pro membership and get like a code. And then we need a registered redirect URI and a hidden client secrets. I'll show that in the next slide. And then once we have those handles, we need to grant authorization, we need an access code, and then finally we can start making and saving queries. So we can start making queries like asking questions and getting the data we actually want. So, I'm sorry, I thought that was, okay. Okay, so here is what it looks like. So there is this link. This is not the whole link, but this link that we click on, and then once you click on this link, you get redirected to this page, connect with application. So once you grant authorization, you get to number 3, and then you give it this URL, and it says code equals. So I don't have the code here, and the code changes all the time, but then you have to copy and paste this code and then go into Python notebook, and then enter the codes here. You see an option that says perform post request, enter that code, and then run the JSON cell, number 5. And then once you run that cell, you get a final secret code. And then from there, you can start making queries, as I said. If you want to know where which CDs the clients are from and things like that, you can start doing that once you have that final secret code. So here is a snapshot of what it looks like in Python notebooks. And these are some of the queries I've made here. This is only some of them. And again, it's a snapshot of what it looks like in Python notebooks. So if I click on one of those queries, I can get this type of information. So here, for example, where are the DataWorks MD members from? So here I got the information that we have about 740 members in the US. We have some members in California and other countries. We even have some members in France, 3 members in France. And then in the US, we have in Maryland 545 members. And then again, Maryland, Baltimore have the most amount of members, followed by Washington, DC. Here I saw that here in DC, it says 49 members, in Washington, it says 48 members. I think it's due to the fact that sometimes when members enter the information for the states, they will say Washington, DC, but then for the city, maybe they enter another city, maybe Tacoma Park or maybe another city. So I'll delve more into it later, but yeah. So here's a visualization of where the members are from. So we can see here on the East Coast, in Maryland, 547 members, Washington, DC, 49. We have some members in Virginia. We even have some members in New York, Pennsylvania, Massachusetts, and the South, Georgia, Florida. Interestingly enough, there are some members also in California on the West Coast. And then, as I mentioned previously, there are some members in Canada. So 10 members in Ontario, Canada. So what's the joining date of the members? So here we can see, this is again a snapshot from the Python notebooks. And here we can see where the joining date. So group profile created, that's where we can see the joining date of the members. It also says the name, but I don't have it here on the slide, but here it is. And here it says join, but this is where they join Meetup in general. And this is where they join DataWorks MD in group profile created. So I was able to send that previous slides to Excel, and that's how I got this visualization here. And yeah, but I could send only 800 members to Excel for some reason. So here, the group DataWorks MD was created in June 2018. So in 6 months, there were 85 members here in blue. So in 2019, the full year of 2019, there was an additional 134 members for the full year of 2019. In 2020, there was an additional 272 members. So it was double the number of 2019. And then in 2021, this year, it's been an additional 309 members. So we've been 7 months into 2021, and there's already 309 members. So I'm thinking if it continues with this trend, it could easily go to 500 members by the end of 2021. So yeah. So again, so I just want to say, so we can see that during the COVID-19 years, we can see that the numbers really spike up. The numbers of who joined DataWorks MD really spiked up in 2020 and 2021 during the COVID years. So what do I plan to do next? I plan to do more queries to collect as many data as possible, to get to know every single need, as much as possible, the needs of the DataWorks MD, the data science community in Baltimore and in other areas, and then see the correlation among those various data sets, a deeper analysis of those data, and then use tools such as GIS and GIT Hub for additional visualization and code sharing. So yeah. How does data science benefit me? So I'm an accounting major, and now I'm acquiring skills in coding and programming. I'm learning about GIS, Meetup APIs, and I think it would be really helpful because I know, for example, someone who's a CPA who now has a software company where he provides software to speed up accounting processes. So I feel like as an accounting major, having IT skills could really benefit me in my professional life. So I'm grateful for that. I'm also an entrepreneurship minor. So now I'm learning marketing skills such as APIs to know about the needs of the market and then to cater to those needs. I'm learning also as a data science student, I'm learning about GIS. So I think, yeah, it would be really helpful in my future endeavors. So yeah, that's pretty much it. So I think I'm acquiring problem-solving skills, I could also, it empowers me with like innovation tools. I will know that some things are possible. If I have an idea, I'll be like, oh, this is possible based on the IT knowledge that I have. So that's it. Thank you very much.
Amivi, that was amazing. And what a great way to kind of thread together the different disciplines that you're so interested in. And maybe you're right, there is space for a new accounting IT software package that you can now create. Thank you so much, Amivi.
Thanks.
We are going to turn next to Loveth. I have your screen open if you want me to share, Loveth. You good with that?
I'll share it.
Ooh, okay.
Yeah, thank you.
Perfect. Go ahead.
Yeah, hello everyone. Loveth, Akinyemi. So today I'll be talking about the grants from Maryland Center on Economic and on Economic Policy Grants. Like I said, I'm Loveth, Akinyemi. So I'm a Baltimore Data Science Corps member, and I'm a Baltimore Science Corps member, and my host organization is Maryland Center on Economic Policy. This is a nonprofit organization, committed to ideas that works for everyone. And this organization is created during the COVID-19 pandemic. The grant in this organization actually is created during the COVID-19 pandemic. So, next slide. In this presentation, I'll be exploring data from the Maryland, from my host. So the data I'll be exploring on the grants are what grants are available to the public, what factors affect the way members receive the grants, criteria to qualify for this grant, and who can get the grants. So the grants available to the public, my focus in this exploration is in Baltimore. So I focus more on Baltimore. I have data more than Baltimore, but my focus for this presentation actually is Baltimore. So for that, what I'll be talking about, what grants are available to the public in the city of Baltimore, what factors affect the way community members in the city of Baltimore receive this grant, and who can actually get this grant. So the purpose of this grant is to help applicants come out of the cost created by COVID-19 pandemic. A lot of things happened during the pandemic, and a lot of people, they go out of funds, some go out of jobs. So this grant is created to bring people back to the normal life, to help the economy peak again, to support families with food, with their medical bills, with mortgage, and other things. So the tools I'm using for this data, the source data is from the state funding for coronavirus pandemic. And the data type is the CSV file. And my tools that I'll be using as a data science student is here tables. What this here tables does is that I use it to sort data. The data I get from the CSV file, I use here tables to sort the data and filter what I need out of it. And the last part of it will be the ArcGIS, which will be like a story map. So the story map is not ready to them, still working on it, but the last part of the whole thing is going to be a story map. So the allocation of this fund by the agency, we have the Agriculture and Nutrition, we have the Department of Education, Health, Human Services, we have Housing, we have Justice and Homeland Security, we have Labor, Transportation, Treasury, and other. And these are the selected local breakdowns. So we have the ARP states, local fiscal relief, we have the school one, the higher education, emergency relief funds, and many more. So for the city of Baltimore, the CRF, the city of Baltimore grants, the first one I'll be talking about is the CRF grants. And this grant, the total the total money given in this grant is $103,559. So the other one, the ARP Metro, is $525,891,651. The ARP City Allocation, we have the Emergency Rental Assistance in ARP, and we also have the Maryland Employment-Based Allocation, which is $154,430. Then we have the very small business portion. These are grants that are given in the city of Baltimore during the pandemic. So allocation for section 18004 of the CARE Act of Higher Education Fund. So for this, there are so many schools in the state of Maryland, but since my focus is based on mainly in the city of Baltimore, so I filter like 4 schools from the city of Baltimore. I have the Baltimore City Community College, which was granted $2,876,155. I have the University of Baltimore, $9,315,657. So then I have the University of Maryland, Baltimore, and I have the Loyola University as well. But like I said, all universities in the state of Maryland get this grant. So who make decision about grant? After the grant is made available to the public, the state make decision about the grant, about who get the grant. So the steps required for applicants to process the grant is, number 1, search for the grant. When you see the grant, put in your application, determine if you're qualified, because every grant has a requirement. Just read through and see what is required from every applicant. Put in your application, and if you qualify, you'll get called and the grant will be automatically yes. So this is a snip from my Airtable where I compare 5 counties in the state of Maryland, and I make Baltimore City the 3rd one, which is my main focus. So I compare the CRF and the ARP grants. The status here says done. That means the grant is available, it's given. So that is why you have the done status right here. So my current findings, the data I use, my current findings from my data is on the Baltimore City grant data. And my next map will be a story map on ArcGIS, like I said. So that will be the next step of this project for me. Thank you so much.
Thank you so much, Loveth, and welcome to Ben Orr, who's here from NDCEP as well. Thanks for hosting. Next up is German, Paredes, and Eli Poussin, physicist from NDC. Thanks, Eli, for coming.
Let me share my screen really quick.
And sorry, Mike McGuire is his professor at Towson.
You can see the presentation, right? Just making sure.
Yeah.
Okay, cool. So good afternoon, everyone. My name is German Paredes, and I'm going to be talking to you about my experience over the past few weeks with the Neighborhood Design Center. So the Neighborhood Design Center focuses on providing tools, expertise, and partnership to accomplish community visions. As you can see on the image below, the NDC staff usually tends to work with residents, local government agencies, community organizations, nonprofits, and volunteers in order to solve any issues that communities within Baltimore may have. As for the data that I have been working with over the past few weeks, we have 2 different data sets. The first one being the service request data set, which focuses on indicating complaints about trash, such as illegal dumpings, as you can see on the image below. And the other data set being ECB citations, which talks about the measure of city code enforcement activities. Before I started working in the code, however, one of the first things I did, since I never really worked with this type of data before, was using the CleanStat dashboard, which basically helped me to get an outline of sorts of what type of results can I get with this type of information. So as you can see, kind of at the bottom, you can see a map of Ellwood Park Monument, And you can see different citations, their locations, their types, and those types of things. As for the tools that I had to use over the past few weeks, we have GitHub, which is where we have been sharing our code with Eli, Art Studio, which is the software we have been using to develop the code, and our Markdown, which basically enables us to create either an HTML or a PDF output of our code. Now, for the actual coding part of the whole thing, one of the first things I did at the beginning of the project was make the citation status map of Ellwood Park Monument. As you can see by the outline, that's the Ellwood Park neighborhood and the location of every citation. The idea of this map was to not only provide us with the location of the citations individually, but also show us the status of those citations. In addition, we use this map to try to find an answer to questions such as, are there any clusters in the neighborhood, or are there any sort of patterns in it? After creating this map, this was my very, very first graph in the project, which ended up being a type of zoomed in version of the information shown in the map. As you can see, rather than showing the entire map on its own, every block within Ellwood Park has its own number of citations. However, people don't tend to use blocks when it comes to talking about locations, which is the reason we made this second map, which is once again the Ellwood Park Monument neighborhood, but now it's broken down into its individual block locations. As for the three colored squares that are around in the middle of the map, we have block 1678, which is the block with the highest number of citations in the entire neighborhood, followed by 6159, which is the second highest, and the third highest number of citations being the yellow square. Then we move on to the second data set, once again, keeping everything in Ellwood Park, which is the area request data set. Pretty much the same map as before. The idea of this map was to show us the locations of the requests, the type of requests, with the idea trying to find the answer to clusters or patterns, same as before. Then we developed this service request closure time graph, which pretty much answers a pretty straightforward question, right? How fast are requests closed within Ellwood Park? As you can see by the table, dirty alley requests all the way at the bottom takes a much, much longer period of time to get closed compared to sanitation properties and illegal dumping requests. Then we develop a service request over time graph with the idea of trying to find patterns throughout the year of how the service requests are either requested or closed over time. In addition, we have been trying to find if there are any particular dates throughout the year where requests either go up or down. After analyzing Ellwood Park on its own, we try to move to the second, step of the project, which is comparing Ellwood Park neighborhood, which is surrounding neighborhoods, which are the ones mentioned in this slide. Here we can see the very first graph from the presentation, the service request map, but in addition, everything around the Ellwood Park neighborhood, it's basically the neighboring neighborhoods and a little bit of these requests. We didn't show all of them because it would have been too convoluted. So we just have a 50-meter outer space around it. The idea for this type of map was to follow pretty much the same questions as before, trying to find patterns, trying to find clusters. Additionally, we are trying to find relationships within the borders of every neighborhood and see how they influence one another. Then we made a citations map, which pretty much asks the same questions. Are there any clusters, any patterns, and how neighborhoods affect each other within their borders, excuse me. Then we made a citation status plot. It's just a different way of showing the information and to compare Ellwood Park with its nearby areas. So it's just basically a different way of viewing that same information shown before. Here we have a citations over time graph. However, rather than only including Ellwood Park, it includes both Ellwood Park and every neighborhood surrounding it. So as you can see, around late 2020, the citations were pretty low compared to about late 2021 when they just spiked once again. Lastly, this is kind of one of the newest things we did. It's a citations table with its purpose being just having all the information in a single page. As you can see on the upper left, you have the requester with all the individual different types of requests. And you can compare Ellwood Park on its own with all its nearby areas. Then you have the current status, the different types, Ellwood Park, surrounding areas, and so on. As for the next steps of the project, we are planning on making large-scale reporting, which basically means just making a report for every neighborhood in Baltimore. We are planning on making report templates that work for every neighborhood as well. There are some errors that we still need to fix. And lastly, we would like to make an interactive user interface so everyone can make their own reports without needing of any expertise or knowledge of the code previously. As for the things I have learned over the past few weeks, being quite a lot, I learned about data analytics back in January last semester. So I was pretty new at the whole thing. So working in this project gave me a much better idea about what data science is overall and how it influences communities, or how communities can use it to, find solutions to their problems and whatnot. Another thing I learned about was all of the issues that residents in Ellwood Park have been dealing with, especially trash-related issues, as again you can see by the image. And I think the most interesting one was just how to conduct an exploratory analysis, in addition to all the general, getting better at coding and those types of things. And yeah, that's pretty much it. Thank you.
I think it's awesome that our students are learning about trash. I think it's a good thing because it is about how our communities sometimes function. So thank you, German. That was fantastic. Next up is Priya. Priya actually comes to us from UCLA, and she is with the BINIA team this week for Data Week. So.
Okay, let's see. Oh, probably
see
last slide. Okay, so can you guys see that?
Yeah.
Okay. So my name is Priya Kanneboyina. I am part of the BINIA Data Science Corps. And for my project, my host team was Basil Labs, and my supervisors from BINIA, it was Cheryl Knott, and from Basil Labs, it was Theo Goatman. So about me, so I'm a UCLA student. I'm an applied mathematics major with a public affairs minor. In terms of like my coding or I guess data experience, most of it has been through a data visualization site / newspaper called The Stack at UCLA. And so there I mostly learned how to use like JavaScript, Python, and GitHub. I've also taken classes and worked mostly with RStudio up until now. And I also interned at BINIA last year, where I was the Data Week intern, like I also am this year. And then let's see, we'll go to the next slide. Yeah. So about Basil Labs, which is my host organization, basically what they do is they collect Google reviews from like metropolitan areas, and they attempt to quantify qualitative consumer data. So they run them through AI to kind of pick up key topics and also conduct sentiment analysis, which is basically taking a review and seeing, does the overall sentiment of the review give a positive experience? Does it give a negative experience? And they kind of base that on a scale of -1 to 1. And so, yeah, it's basically a way of understanding consumer perceptions. And they've done this for a lot of cities in America, but this was the first time I think they took a look at Baltimore. And so, yeah, it's basically understanding patterns in citywide consumerism, and they take all sorts of data from the reviews and make all sorts of like insights. So for me, this was a very like exploratory process because I didn't have a very specific task to fulfill other than just like find something in the data. So to start, like I said, it was a lot of exploring. So I kind of had to look into the like types of questions I'd want to ask. So I was really interested in public transportation because personally, I was born and raised in Maryland, but it's like outside of Baltimore. So a lot of the times I've been to Baltimore, I've taken like the bus and stuff. So I've been around that mostly. And I wanted to see if it affected review sentiment. I wanted to see if different areas had different perceptions of public resources, basically analyzing like neighborhood and community differences, and also comparing public and private resources. So like stores versus parks and libraries and things like that. And the data and tools that I use throughout, or I'm currently using throughout this project, is the sentiment analysis of Google reviews from Basil Labs, and then the vital signs data from Binia's open data portal. And the data types are shapefiles and CSV mostly, and the tools, I'm currently mostly working with Tableau, but I want to make a story map and I want to try working with ArcGIS, so hopefully that will happen. So to start, I actually just started by looking for geographical patterns between review sentiments by community statistical area, which are like basically a way of grouping Baltimore neighborhoods so there's not as many, because there's like tons of Baltimore neighborhoods. So if I went by that, it would be almost impossible to get any sort of like aggregate measure. So I went by the CSAs, which I think I want to say there's, actually I don't want to say how many there are because I honestly don't know. But wait, how many?
55.
55, yeah. So what I did to do that, because the reviews don't have a CSA associated to them. All they have is an address, a longitude, and a latitude. So I did a spatial join in Tableau, which is something I had to learn because I'd never used Tableau before. And basically I made points out of the longitude and latitudes and joined them so it intersected with the community statistical area. And then after that, it was really easy because all of Binia's data, or all the Binia data I used, had the community statistical area. So I could just join the rest of the data by community statistical area. So here's kind of a picture of it. And I just had all this different vital signs data that I was exploring. And then the extract, you can't see because I'm not allowed to put up like the Google review data, but it's just the Google review data. So this is one of the first like preliminary maps I made. It's the first one on the left is sentiment score by community. And I don't have the scale there, but it goes -1 to 1, but most of these are in the higher range. So I didn't find much. As you can see, like it seems to vary and doesn't have a very clear like pattern in it. And then I also went by average review. And as you see on the side, it goes from 1.4 to 5 stars. Also doesn't have a huge pattern, but I'm still in the process of exploring, so maybe I will find something. And then, okay, there we go. And then, yeah, I continued to use Tableau like you saw with the spatial join, and I tested the review data against various vital signs. Some of them included median household income, affordability index, and then just more data about businesses. And my findings honestly weren't that interesting, unfortunately. And there wasn't like a huge correlation between anything that I found. So these are some of the ones with the stronger correlation, which you can see isn't even very strong. So this is affordability by sentiment score and median household income versus sentiment score. And earlier I did mention that I was interested in working with like public transportation and public versus private resources, but at the time I didn't have the full set of Baltimore data. So the points that I got, it looked like this, but almost like sparser. So I wasn't confident in like presenting that or showing that with any kind of findings because there just wasn't enough data in that case. But moving forward, and I think I'll mention this in a later slide, I have the full set of Baltimore data now. I just got it like this week, but I haven't got a chance to look into it because I'm doing data week. But hopefully I might be able to find some correlations between vital signs and the data. So one of my next steps actually is pivoting subjects not completely, but a little bit. So something that Cheryl, Theo, and I talked about was that Binia is in the process of renaming some of the community statistical areas because not all of them are what people identify as those areas. There's a few that are really outdated or the name doesn't have any real association with the community in the neighborhood. And so what I'm actually interested in looking at now is kind of mapping out to see where those names get mentioned, like the community statistical names, and is it where the community actually is? Does it vary widely? Does the name just not get mentioned at all because it's just outdated or never used? So these are some kind of visual examples of it, but I'm actually going to, what do you call it? I'm gonna kind of search like every single one, but this is just like 2 of them. So this first one is downtown. So basically what I did was I put in a search through all the reviews if they mentioned downtown, set it to true or false. If it's true, it's orange. And then if it's false, it's blue. And so the first one on the left is just a general mapping of it. And then the one on the right, I overlaid the community statistical area. And you can see that darker spot or that darker shape is downtown/Seton Hill. So you see that it's actually pretty close, but it does also go kind of north a little bit of downtown. But yeah. And then the second one that I want to show you guys is Inner Harbor, which I found kind of interesting because it's like shifted up slightly from where it is. So same thing here where I put in a search in all the reviews for if they have Inner Harbor in their text. And then I mapped it with the overlay and you see Inner Harbor is right there. It's the darker outline. And then you see that it's like the most mentions are actually like on the border of where Inner Harbor is. So yeah, my final project and my next steps hopefully is going to be an Esri story map, but never used it before. So I'm really excited to learn about that. I'm going to continue working with like mapping it by the CSA and the mentions of the community statistical areas to see what lines up and what doesn't. And with that, I'm hoping to use ArcGIS a little more because thus far I've mostly used Tableau. And like I mentioned, since I now have the full set of data, once I get all the sentiment analysis and everything, I will try to look into more vital signs correlations to see if there is anything there or if I can go back to some of the original steps in my project. And in general, keep learning more about Baltimore and data. And then I don't have a slide for it, but since everyone was mentioning it, I also want to talk about how data science benefits me. So because I'm in like applied math and public affairs, I'm very interested in like quantitative data in the social sciences and how to quantify qualitative data. So I am really lucky that I got to work with Basil Labs because that's exactly what they do. And I just wanted to say thank you to Cheryl and Theo and also Seema for helping me along the way. So thank you.
Great job, Priya. And sometimes when you don't find a correlation, that's interesting too, because that tells you something either about the data itself, like maybe on Google reviews, things are actually pretty plateaued. Maybe we don't get crazy outliers of maybe everything is either really bad or everything is really good. Who knows? That's something you might want to think about. But the name change is very interesting. And for those of you that don't know, we are in a surveying mode for changing your community name. So if you want to take that survey, it's in the chat. And last but not least is Kaitlyn. And welcome to Kaitlyn's host, Donna Cobb, as well. And you're going to learn more about Return Home.
Right. Hey, everyone. I'm Kaitlyn, a BINIA Data Science Fellow. I'm going to share my screen and get started.
Your voice is pretty low.
Okay, let me fix that really quick.
For me.
Oh,
Yeah, that's better. Definitely better.
Oh, you can hear it? All right, maybe.
Yeah, that was better.
Okay. Actually, I have my earbuds reversed. I'm going to switch them real quick.
Okay, good.
All right, just holler at me if you still can't hear me.
I can hear you now.
Okay, cool. All right. All right, can you see my screen?
Yep, you're good.
Awesome.
Yep, perfect.
Cool. All right, so
And I wanted to mention that Giovanni Vincenti is here.
yeah,
Her advisors here at UB.
all right, so the work that I'm doing with BINIA is developing a web scraper for Return Home, which is an organization that helps with the reentry of previously incarcerated citizens who are looking to return to Baltimore. They also, so Return Home they have their own website that compiles a wide range of resources for returning citizens, and these can be things such as food, resources for housing, for job training, and addiction counseling, etc. And for this project, the work they needed help with was building on a web scraper that they already have created and making it better. A lot of it is focusing on creating a little more automation, so there's not as much manual entry that goes into getting the data from the websites that they are using to provide all this information. So each website that they use, maybe it's Goodwill that provides services for food, or maybe even job training. So they can provide the contact information for all the websites that they use as their resources. The tools that I'm using are Python as the language. We're using Google Sheets for data storage. It's like the back end of the project. We're also using Flask and some Bootstrap for the front end of the project. I'll go more into that and show some visuals on that. And we're also using GitHub for version control. And I'm saying we because the person that I'm working with is like my mentor and the developer for Return Home, who's working on this web scraper. So we're working on it together to build it up. So we're cutting down on manual data entry for the website. We're improving the accuracy and automation of gathering the data, and we're improving the ease of use of the system. So currently it's a little hard to navigate the back end. There's a lot of information on the sheet that we're using. So there's a lot of loading issues and you got to scroll a lot. So really cutting down on the time by improving the ease of use of the system. So when we started the development, we first connected the web scraper and we tested it for accuracy. We targeted the XPaths of these certain values from each website. So basically, I actually have a picture of it. Do I? Okay, the XPath can be accessed through the inspector tool. It's usually like F12 if you have a Windows computer. So you right click the information you want, you go to copy, and then you either get the XPath or the full XPath. We used both and they both seem to work. And so on the right side of the screen, you can see the XPath is this HTML/body/div8. So when we're gathering that data, it outputs the address that's right underneath. So we're directly pulling that information using the XPath coordinate from each website. And this is really awesome because if the data if the information was updated, but it's in the same spot, then it can automatically update itself without us having to go and be like, oh, they're different. The addresses are different. The phone numbers are different. So yeah, improving the ease of use of the system through using the XPath values. I think I just mentioned this, but so to improve the accuracy of the system, we compare the currently scraped data that we just got to the previously scraped data to make sure that there are no differences. And if there are no differences, it passed the test, it comes out as true, and you know everything is fine with the system. You get an email saying that everything checks out. And if it fails, it'll send you feedback through an email that says, hey, this came out false, there's something wrong, you need to check this out. And then for the interface, like I was saying, it was hard to navigate, and it took a lot of time to enter in information needed that we couldn't automatically grab. So we created a simple HTML page using Flask, which is, it's like a web application that can be used for Python. And we made it into a form that you can enter information into and pull from. So it provided a streamlined way to view the data and to allow point and click options for data entry. And I'll show you, it's kind of hard to, I guess, to visualize that, but I'll show you in a second. So this is the website here. You can see that they get the address and the phone number. But in this current state, it can't automatically update itself with the current address and phone number. So there may be times where there's misguiding information for people that really need to seek out the right information. So we're trying to work on fixing that. And excuse me, I'm gonna take a sip of water. I already explained this, again, is the XPath coordinates that we're targeting to get the information that we need from each website. And here is a lot to look through, but it's fun. So basically, we, in this little snippet of code, just for an example, we're taking the value from the Google Sheet that has the phone number and the value that has the address, and we're comparing it to the value that we just scraped, the value that we just took in. And if those two values match each other and come out as true, they pass the test, and then the output gets emailed to the user, whoever is on the email list for development. And then you can just automatically see whether or not you need to go in there and change something. This is the interface that we're working on. There, it's a little messy up here with the string filters. We need to remove that row, but that's for further development. So you can see these are values taken directly from the Google Sheet. So we use Google APIs to get the credentials to be able to access the Google Sheet through our system. We get the address and the phone number, and you can click view row, and that takes you right to the information that is in the cells, and you can go to each of these and edit the text if you need and submit, and that transfers the information to the Google Sheet. So one awesome thing about this is if you need to update the XPath, maybe it's switched to a different page on the website. So this is an easy way to go through and click that. And a great thing about this is that, you know, when you click on the row, it pre-populates the data. Right here, it doesn't populate everything because we're still working on fleshing it out, but you can see a little of what we're doing. And this was an awesome learning opportunity so far. So I learned a lot in these past couple of months about the challenges of web scraping, because every website, I thought it was, you know, a one size fits all kind of thing, but every website is different and data may move. You might not even, you know, get the data that you want. Some websites, you know, don't have phone numbers, don't have addresses you can go to. So you have to figure that out and see, you know, what you can target to get the information you need. And a lot of data that we were working with was maybe there was a lot of spaces before it, or some phone numbers had like phone ... and then the phone number. So a lot of data needs to be cleaned when you're taking it in. There's a lot of work that goes into cleaning up the data. And we are in the process of working on that and cleaning the data so everything is nice and in the same format as well. And also websites change without prior notice. So you'll never really know, you know, when information has changed. And we improved this with comparing the values of the currently scraped data to the previously scraped data. And I also learned like how data can help. It's not just, you know, going through product information and pricing of things and all that. It really can help people that need it, you know, and it's really awesome to be able to work with an organization that's focused on such great things. It's been really, really cool. And the next steps for this project and for future data work is to improve the easy use of the system. The interface could use work. I'm not much of a front-end developer, but it would be nice to have it nice and neat. Also focus on standardizing the addresses for GIS purposes, maybe mapping the data and finding patterns within the data would be a really interesting side project to go into. And also researching, working with dynamic websites. So a lot of the websites that I'm working with right now are static, and it's really easy to get the information that I need. But with dynamic websites that, you know, rely heavily on JavaScript or Ajax, it might be a lot harder to dig for the information that you need. So researching more into that and seeing how that applies, or how often really that applies to working with a web scraper. So yeah, thank you all for listening.
Fantastic, such a good job of explaining what may seem like minutia to those that may do this all the time, but it's so interesting for those that may not know how to do what you just did. So thank you for doing that, great job. So it is 6 o'clock, so for those of you that do want to leave, feel free to do that. And Logan, you can go ahead and turn off the recording, but